Hey there. So, I wanted to talk to you about this conversion project that I've been working the last couple days that I'm kind of excited about. I've been working on converting the MiniCraft Java source code into MiniScript for the mini micro here. And I was going to wait until the entire conversion is done and then do a massive code review. But I thought I would go ahead and talk through a little bit of what I've been doing along the way. It might make it a little easier if I do this in chunks. I actually really like some of the, just developing the mini micro is kind of nice. There's things like the being able to view the assets directly in the environment here. Just kind of fun. Plus and minus to zoom. Now, if we can zoom in and get the arrow keys to move that image around the screen, then that would be perfect. So maybe someone will put that on the future request list. But so here's the project. Been calling it MicroCraft because it's for the mini micro. And I'm sure that name is so generic, I'm sure it's been used 100 times before, but unlike all those other versions, mine uses the fun little micro character in the name. So there you go. And let's see if I can find my mouse cursor here. I have it up on GitHub. Ultimately, I mean, you can follow my Git repository here. I should have the entire conversion done in a couple of days, and then I'll be posting another video to walk through the results. Right now, the Java code lives alongside the MiniScript code as I'm doing the conversion. And ultimately, I'm going to be setting it up to publish to itch.io. I have a page over there. itch.io. I think it's that link. Oh, nope. There, tradetomes.itch.io. Got a couple projects up here. And I think what I'd like to do, I'm going to get the MiniCraft source code going. And then we're going to have a couple of videos talking about how to get the performance up to where it needs to be. I'm going to talk about that in just a minute. As it is, like, Notch wrote the MiniCraft game in, like, what is it, 24 hours, 48 hours? The performance, it works fine for the way Java is structured. It is not good for the mini micro. And I'll tell you why soon. I have this RPG-like game that I've been working on. I have the microhack game. What I'd like to do is pull some of like the story ideas from the RPG-like game, maybe some of the music assets, and some of the roguelike rules out of microhack, and merge that all into one big project, which I think could be lead to something really interesting. But you know, one step at a time. So you're welcome to follow each of those games, tradetomes.itch.io, and MicroCraft GitHub, which I will be posting in the video description. And you are always welcome to like and subscribe my videos, because I find it encouraging, because then you'll be sure to get these updates. So, all that aside, what I'm doing right now, most of it is really grindy work, which is why I'm doing it most of it offline. See that here's the class that controls the oven. Use the oven to make bread. There's a crafting file. Oh, where's that? Has the oven recipes. Where are those oven recipes? I'm sure they're right in front of me. Oh, there's only one. You can cook bread in the oven, and that is all. But basically, I take the Java class, I create a MiniScript file for it, and then I convert it one line at a time. Here, we'll just do them right here. The oven is a really simple example. I call the superclass super.make, and make sure to do self dot for the properties. And return self. The reason I have to return the self is because when I'm constructing this, I'm doing something like this. New oven, or like oven equals new oven dot make. And if make doesn't return self, that line will fail. And I've also been trying to use the JS doc descriptions in the comments, just for my own sanity. Because there's so much code I'm converting, and I'm only marginally familiar with it, so it'll be very easy for me to pass the wrong types in. So you got player.game.set menu. This opens up the crafting menu. You have to actually construct the crafting menu, pass it the oven recipes, and the player that's doing the baking. And that would theoretically be a good conversion of the oven class. Oh, also oven extends furniture. So oven equals new furniture. And then at the end of every single one of my files, I am returning the class. I'm doing that because if you go down into my main file, in Java, this is all in separate namespaces. I'm keeping the existing folder structure as is. I'm adding all of those import paths. And then I'm using this require function, which you'll see it in a lot of MiniScript code, but it is not built in. You have to provide it yourself. Core util, define require, which basically imports it and then loads it into the modules, into locals, returns it, and lets us do this. Globals.listItem equals require list item, globals. Well, I haven't imported the oven yet, but I'm going to. Eventually you'll see all of our different entities and items down here, which is going to make this list really big, and I might end up putting it in another file. I'm not decided yet. So the oven is really simple. I'm working on the simple ones first. Oven, furnace, furniture. Some of the more complicated ones is like the final boss in MiniCraft is this air wizard. It's like the way MiniCraft works. You start on the ground level and you build some tools that allow you to go deeper, and then those deeper tools allow you to go even deeper. You go all the way down, build the final tools, and then you can use that to break through a special staircase on the top level, takes you up into the clouds, and you go beat up the air wizard. I don't know why. He was minding his own business. You go invading his space, kill him, win the game. I don't know what the air wizard did to deserve this, but that's the way the game works. But yeah, the air wizard's logic is a little more complicated. So I'm saving that one for a little bit further in. And some of the things I'm converting, I'm trying to mostly keep the classes the same, but the sound Java file I renamed to sounds because the mini macro already has a predefined sound class. That one. You can do a lot of neat things with it, but you should not overwrite it. It makes the system mad. Did I do that wrong? There. So the Java program has a collection of assets built into it, a bunch of WAV files and a couple of PNG files. Only icons is used. Icons 2 is never used. And basically, I am just making a simple map with all of the sounds we need preloaded. Playing them is very simple. Sounds dot... Oh, let's see those names. Pretty sounds. Got player hurt, player death, sounds, player death, play. Sounds, pick up, play. That monster heart sound is played whenever. I think I saw it being used up here with was it the smash particle? Yeah. Whenever it creates the smash particles, when you're smashing something, it plays the monster hurt sound. So the conversion is fairly straightforward, but there's just a lot of files that need to be covered. The things that are working now, well, the Java project starts in game applet, which then goes into game. I'm replacing both of those with just my main program, which until recently I had it working with a simple event loop where it checks these 6 keys in the input handler to see if they were clicked and then print which one was clicked. But then I hit a critical mass of how many classes I've implemented, and there's so many interdependencies that I have to implement basically all of them before I'll be able to get the thing to run without a syntax error. I'm using the events library, basically run the event loop, and then on update, it calculates how, if we're behind by a certain number of ticks, and if so, then go ahead and process all those ticks in the game. And on each tick, it will update our input handler and then check each of the keys to see if they've been pressed. The Java input handler, it implements key listener, which is not a thing in MiniMicro. The events library has a key handler, but it's used a little bit differently. A subclass for key, which for my purposes, what I ended up doing, I implemented an input handler miniscript file, and I just had the key class is separate from the input handler. I defined a set of keys, but I only returned the input handler, essentially making this key class private, which it works. It creates the keys. They're not mapped to anything until the main event loop does something like this. Up, down, left, and right. On key up toggles that key to false. On the key down, it toggles it to true. And it does work. I tested it before. Until I get more of this code done, you're going to have to take my word for it. And once this is all done, I'm going to demo the final result. And I'm not expecting good performance right away, and I will show you why. In the Java code, we start with game. It extends canvas. So you basically have a pixel canvas sitting in a window. And then you have this thing, the buffered image, which actually stores the pixel data. And it gets even more fun. You actually have an array of pixels, a one-dimensional array, not a two-dimensional array. So you have to do some math to figure out where in your one-dimensional array your pixel should be placed. And then if we go down here, is this the right place? In the render function, we're basically iterating over the entire screen worth of pixels and plotting each one to the display. These screen classes actually have another 2D array or 1D array of pixels, and each of those needs to get plotted onto the display, and the whole thing, it's drawing everything one pixel at a time. It's gonna be pretty slow in the first iteration. I'm just trying to get it up on the screen. Second iteration, going to try to properly implement off-screen pixel displays. Let me load up the screen class. Where did I put that thing? It's in the graphics folder, GFX. So this is a clone of the Java screen class. And there's the one-dimensional array of pixels. And when every render function just updates values in that array. And so in the second round, we're going to convert this to use an off-screen pixel display. In the third round, we're going to be converting it so all of these entities, instead of shooting pixels off to a pixel display, they need to be using sprites. If we go back to our assets, these tiles are 8 by 8 pixels. The sprites are designed to be 16 by 16 pixels. Well, it's designed to be 4 tiles drawn separately. Because it's like, if this little guy is in the water, it's only going to draw the top 2 tiles. So we're going to be implementing basically our mob sprites and player sprites as sets of 4 mini micro sprites. And then finally, go to the level folder. Playing with these levels is going to be fun. The levels work the exact same way as everything else. When you really get down to rendering, is just pushing individual pixels out to the display. We're going to be converting that over to a tile display, tile maps. And once all that conversion is done, I'm expecting we should be able to get pretty good performance out of this. And it's probably going to take a while to get it done, but it's going to be a lot of fun to set up. And then I am looking forward to seeing what the MiniScript community can do with modding this thing. I will also be modding it. Maybe we could have a great big modding competition. It's going to be loads of fun. And I hope you can join me for this adventure. So stay tuned. I'll be posting more about this properly within the next day or so. So that's it for now. See you later.